It seems obvious that nothing can be faster than a falling human. A skydiver drops through open air. A skier only slides on snow. But physics tells a very different story. And the answer might surprise you. Where speed on skis comes from, speed on skis isn't just about steep slopes. Two factors matter most: ski material and snow conditions. And surprisingly, these two are deeply connected. To understand why, we need to look at how skis actually move. Why skis slide at all? Snow comes in many forms: dry, fresh, icy, wet. But in physics, there are only two types of sliding: dry and wet. Ideal conditions occur around -3 degrees Celsius. At that temperature, a microscopic layer of water forms between ski and snow. It's created by friction and slight melting. The ski creates its own perfect surface. But outside this window, things change. When snow slows you down below -3 degrees, sliding becomes dry. Static electricity builds up and increases resistance. Above -3 degrees, too much water forms. Capillary forces pull the ski toward the snow. Speed drops again. Perfect snow is rare, and speed depends on adaptation. Why graphite matters? Modern skis are mostly plastic, but almost all include graphite. Graphite prevents static charge buildup and conducts heat away from the surface. That keeps melting under control and maintains optimal glide. More graphite means faster skis and higher cost, but manufacturing matters too. How pro skis get faster? Recreational skis are made by extrusion. They barely absorb wax. Professional skis are sintered. High pressure creates microscopic pores. These pores hold wax tailored to specific snow conditions. That's how racers gain speed where others can't. Now let's talk numbers. How fast can a skier go? An advanced recreational skier can reach about 100 kilometers per hour. Professionals go much faster, up to 200 kilometers per hour. The world record exceeds 250 kilometers per hour. That's faster than many high-speed trains. Now compare that to free fall. Terminal velocity. A skydiver doesn't accelerate forever. Air resistance limits speed. In a spread eagle position, terminal velocity is around 190 kilometers per hour. That's the maximum without special suits. Which leads to an unexpected conclusion. The real answer: intuition says the skydiver should win. Physics disagrees. A skydiver is limited by air drag. A skier uses friction to their advantage. Under the right conditions with the right equipment, the skier is faster. Sometimes, physics beats common sense.